My phone tells me that I'm at Spanky's. I'm making this recording at Spanky's. All right, y'all get 913.33 pounds. 1821. 208.82. 265.22 for number 3. 458.33 for number 4. Good. We've been over for what, 3 days? That's okay. It's just going to get harder. Tucker wanted to know about hydroponics. You know, we're going to start getting into milligrams and liters next week. Next week, we're going to get into milligrams and liters. And it's just going to take me a minute to set that up. But we're going to apply this type of math to that hydroponic system. What's up, Isaac? Good. Okay, you had the front eye. You had the front eyebrow. Like, where did you get that number from? Yes, sir, Jeff. Sure. She's like, at this point, I don't care. Everyone feeling pretty confident in this? Nick, you doing okay back there, brother?
I'm on number 9, man.
Cool. Did you tracking on this? That's what's up, man. That's what's up. It takes a little bit of repetition. Set it up the same way every time, man. And when you get these basics down, it's kind of like the Karate Kid. He had him putting the jacket on and taking the jacket off and all that stuff. Wax on, wax off, and then when it came time to use it, it just came natural. So like in the field or on a test or wherever, you're going to go, oh, boom, and I'm going to know how to do this without even knowing that you know. All right? So I think last time we left off, did we calculate the cost for the other blend? Make it to, did we get here? Or is this the? We jumped from here. We calculated this, I believe.
Yes, we did.
And then we calculated the cost for it. Okay, and so then over here, we're gonna, on the next page, we're gonna do the same thing for a different blend. So the first thing we need to do is figure out how many pounds of nutrient are required in order to make this blend. Luke, did you do it already?
Yeah.
Yep. Got one. Set the hook. Go. Love these things. So we're just going to set it up the same way we've always been setting this stuff up, y'all. You're either going to multiply or divide. Like, I'm not going to throw any tricks at you in the beginning. The industry will throw the trick at you. I'm here to train you, not trick you. And getting these little fundamentals down in the repetition, you're going to be like, oh, and then you'll be able to see the mistakes. Once you know how to do this, you'll be able to see the mistakes and go, oh, you know what? We didn't account for that. Did you get it right? Did you account for the nitrogen and the DAP? Kenzie, do your nails glow in the dark? You can get some, like you could make them glow in the dark. You could get you one of those chem lights from Walmart. Yeah, buddy. Yup. The thing is, no one would ever know the day after. They'd be like, Mackenzie's nails glow in the dark. Where'd you get that at? Special blend I made. $10 for a bottle. Get rich for about a day. Top all those numbers. There's a lot of numbers in there. You do it too, Josh?
Yeah, I think I have the whole packet done. I need you to look over the last problem and tell me if I got that one right.
Yeah, that's the tough one, huh? With the pots?
Yeah, that one got me a little bit.
I threw it in there for a minute because I know some people. Did you do the pots? No? Okay, that's what's up. Did you try the last one?
No, I didn't try
You
this
didn't
one.
try the last one? I finally found a way to make some soils actually apply.
Question.
Yeah.
On the last one, are you supposed to make an assumption?
You are.
Okay, good. I think I got it.
You'll at least get it close. It's really just about the critical thinking process.
Okay, gotcha. Yeah, I think this one's right.
Ethan, did you try it? You looking at it now? No? So these little math skills will go together when y'all start doing pot studies. Not that kind of pot study. One day, huh? Maybe in Colorado? Is that where you're going?
I'm probably going to Oregon.
My man, Portland, huh?
I don't know yet. Maybe Eugene. I'm looking for maybe not Portland because it's the big center, but somewhere with a larger population. They got a lot of market farmers out that way.
Yeah.
I can find a Mr. Miyagi out there.
There you go. The bonsai trees. All right, everyone get some of these numbers. We're making sense. Isaac? Okay. Y'all saw where I subtracted. Right here, I got how many pounds of nitrogen from this blend. And I put it in here because I did it on paper. How many pounds of nitrogen did I get out of this? 54. Yeah, 54.78.
7, 8.
So I subtracted that from the 420. 420 minus 54.78. I now need 365.22 pounds of nitrogen. Then I just do it just like I normally do. And this blend is actually really good because you fill most of the 2 tons up with material, because all they do is they throw some dolomitic lime in there as filler, and you just pay a lot of money for a little bit of stuff. Yeah, you got the look, brother.
Slowly falling.
Okay, cool, man. I mean, I'm gonna put some more calculations. I'm gonna put a calculation assignment in iLearn that you can do over and over and over again until you get the best score.
Yeah, reps. That's
What's that?
Reps.
Just over and over and over again, man. I mean, they just beat this into my brain. God, we did this so much. And then I'm like, Luke, once I figured it out, like, I just started making up combinations. And so then, Tucker, when I was in my PhD, I had a nutrient solution that was given to me, and I had to bring it to volume. So I had to change the concentration intentionally. So I did it using this open formula. I was able to figure out how much material I needed to add, nutrient I needed to add to like 500 gallons of water. And so I'm not going to mix 500 gallons of water. I'm only going to mix 1 gallon. So I had to condense and concentrate that down, dump that 1 gallon into 500 gallons, and make it come out. Yeah. So I used this formula, not knowing it. Like I learned this in soil fertility in my master's, and then when I got to my PhD and I had to change the nutrient concentrations, I used this in order to figure out how much chemical I needed to add to this water to make it all even.
How much nitrogen did you get from the down?
We got 54.78.
54.
So 54.78.
54.78. I got the recording thing on my phone, so I'm recording this for a couple of students who are feeling under the weather. And then I will post this online today. I'll get all the original assignments. I'll post all the original documents and these keys online so you can go back and work them as well. All right. I want to look here at this back page at the last problem. So today we'll figure out which research groups we're going to be in. And then y'all start figuring out a study. I figured the 3 of y'all over there would want to do some hydroponic something. And then we'll match everyone up else kind of into something. At least the groups, and y'all can start talking about what projects you might want to do. All right, so you got this pot study that you want to do. And so we go collect the soil from Shipley Farm, and, you know, we send it off for analysis, and the soil test comes back and says it's a little low in phosphorus. And it recommends 32 pounds of P2O5 per acre. We didn't pick up an acre. We only grabbed a couple of kilograms. So how would you go about kind of standardizing the phosphorus concentration in there? Josh, you want to walk us through this?
So the assumption that I made that was that 1 acre contains approximately 2 million pounds of soil. And from that point, I multiplied 64 by 6.5 to get the total pounds of soil needed, 416 pounds. I then divided 416 by 2 million to get the number that you would get for how many acres technically worth of soil that you had, or that you would have.
Per pot?
Yep. I did that afterwards.
Okay.
Okay, so after that, I multiplied that by 32 to find the pounds P2O5 needed. And then I divided that by 64 so I could have the final number.
You did yours, you have a number on a per pot basis, right?
Yes.
Okay. And how many pounds of 1846O did you end up needing per pot?
The one I got, I think I got it wrong.
No. You just went about it differently. How many pounds of
Um,
fertilizer do you need per pot?
0.000104.
You need 0.0104 pounds of 1846O per pot.
So I did some calculation wrong. So I did a different color.
Yeah, okay. Yeah, you got 3 zeros.
Mhm.
Yeah. So what he did is he was able to figure out how much 6.5 pounds of soil would need to match that 1 acre. And so there's only a few times that we need to do this equality. So, but he made the right assumption was that there are 2 million pounds of soil in 1 acre furrow slice. So we typically do that per acre furrow slice. And so if you have this, if you run into something where you have to standardize a small pot study, how many of y'all are not going to do a pot study now? Mary Helen's like me. Don't put me in the pot study group. But like you do see that you can get in and out of that several different ways. All we know is that 1 acre furrow slice weighs 2 million pounds, and I need 32 pounds of P2O5 per that 1 acre. Well, I only have 450 pounds of soil because I know I'm only going to need 416. Always make a little extra. Right? Because it's not always going to add up to be exact. You're going to spill some and lose some over the course of the time. And so then we just, now that we have what we need per, this would be a lot of soil. So we did this 0.0072 pounds per lot. This is where I cross multiplied and divided to get the equality. And then I need 0.0072 pounds of P2O5 divided by 0.18, and that gives me 0.016. Look, if you take this out one more time, you get your 3 zeros.
Okay.
Right?
Gotcha. So what's the correct answer?
I think your answer's correct.
I'm going to go ahead and write mine down in this order.
Well, I'm going to post this online. But like when you start doing small experiments like this, like you kind of have to start thinking, how am I going to standardize this thing? How am I going to make sure that everything is equal? But if you start with a soil and you need to increase the concentration or the nutrients of it, something to think about. It's kind of what I love this stuff. I mean, because my boss raised me on this, y'all. I did an experiment where I took, we were testing out different fertilizers and fertilizer nitrogen sources with Agritane and fertilizer stabilizers, and we were trying to emulate like a field in a urinalysis cup. Right? So we took 100 grams of soil and we made a slit with a paint scraper or like a plastic putty knife, and I had to back calculate. Not only did I have to back calculate going from a 2 million pounds of soil to 100 grams, but then also that we are calculating this soil in the field as a square. It's a cup and an area and like blowing your brain. I still got the sheet because my boss sits all over the place, just front and back, and he's doing all these calculations, all the units. He goes all the way out to milligrams and comes all the way back to grams. I know it's just insane to think about how we do this. Everyone kind of good? Maybe not so much on this back sheet, but I kind of wanted, yeah, what's up?
Sorry, me cut you off.
You're okay.
Where'd you get that 0.0072 pounds? Me too. I don't know if I missed that part.
So
That was just
what-
assumed.
what this really looks like so when you cross multiply and divide by 2,000, that answer is 0.0072. Did I do that right? Luke's back there. Did I get it, Luke? Okay. So you cross multiply. This is like the time when it's an equality. If you've noticed in most of my calculations, in most of the calculations that we've been doing, there's a multiplication right here, not the equal sign. And so I had this problem in my soils class, and especially in 2000, where students were wanting to cross multiply and divide because it kind of looks like that, right? This kind of looks like I should be cross multiplying and dividing, but it's not. We're multiplying straight across and coming up with an amount over an area. This would be kind of like an area, but that's actually just a weight. So you got to think about that. We got areas and weights and volumes. What's up, Tucker?
On this bottom one right here, you put 18 pounds of P205. Supposed to be 0.46.
It is supposed to be 0.46. Does the answer still come out to be correct? 0.0072 divided by 0.46. About to find out. Good call. So this should be divided by 0.46, not 0.18. But the final answer is correct. Okay. I'm going to change this to
You just use 450 pounds of soil as the denominator there, just, you know, it's a constant.
right, because I got 64 pots that I'm going to put X amount of soil into.
Right.
So I figured out how much soil I was going to need overall. So I needed 416 pounds, and I threw some extra in there. Plus, it makes the math really easy. And then I just did a simple equality to figure out how much P2O5 I needed, which this is now my rate. I need 0.0072 pounds of P2O5 per lot. This is a lot of soil. Not as in a lot, as in like a lot. It is a lot. Like, this is the type of stuff I sit and do all day. And now think about that. I had to be able to back calculate all that too. But I love math like this, so that's why they send me on to be a PhD. All right. What's that?
On 1846 zero, they use like odds concentration.
It just happened to be whatever fertilizer it is. Like these things that I'm giving y'all, the main thing that's going to change are the numbers. The fertilizer source is what's going to change, and the rate. You're going to get it back from a soil test, and you're going to, like, this is a 3145/60, but that's not what that is. It's impossible to make this. What they have here is it's impossible to make. It's really more like 13. Because if we did an open formula on that, it would be like 4,000 pounds of fertilizer in a 2,000 pound bucket. It just wouldn't work. But whatever fertilizer source you have available when you get there, wherever you go, they may have some stored up. They may have some like, hey, we got some fertilizer in the back. Ethan wants to go work at a golf course and they've got some fertilizer back there. They're not buying any until you get rid of that. Well, man, what am I supposed to do with it? So the numbers will change. This 18460 might change. It might be Osmocote. It might be 1919. It could be 13. It might be 0460. I don't know what it's going to be when you get to the situation. But I do know that you can apply these principles to the math so that you will be successful when you get in that situation. The only thing that's going to change is the numbers. The methodology is still the same. All right. We got maybe just a little bit of time left. What time is it?
For you to get a watch.
What time is it? How much? 3:54. All right. Yep. Oh, someone raising their hand. All right. I think let's make the groups. I know y'all three are going to want to do something hydroponic, small scale, and we'll go over how to do that later. How about you two and Sarah, Joe, and Mary Helen? Y'all four work together. Who else did we have? And then we'll put Isaac and Ethan and Nick and Luke. And then over here in this back group, we're going to have Austin, Chloe, Hunter, McKin, and we have Madison that needs to go in somewhere too. We'll put Madison maybe with them. Okay? So at least you know your groups. Y'all can kind of discuss maybe some project. We don't have to do that right now. We at least got the groups assigned. I'll try and come up with some project ideas, and then we'll work on that on Tuesday, okay? What? Like, what are we doing? I'm going to bring some topics up, and y'all can kind of think about if that's something that would be fun for y'all to do. Yeah, like a research topic, like something to do with nitrogen.
I mean, I just didn't know if it would be just like a giant calculation or something.
No. This must be an actual experiment. Like if you're actually going to write down the materials and methods, we're going to test nitrogen uptake in it's based on in-source, so like urea, 13, and poultry litter in tomatoes. We're going to grow tomatoes, and we're going to give them these. Well, I mean, we're going to grow them for a month or two. Hey, I want y'all to think about something else too. We're only going to grow this for like a month and a half, maybe 2 months. So they're not growing out a full crop. Like y'all are going to graduate. Some of y'all are graduating in a couple of months, right? Screw this project. So I want y'all to think about this. We're going to do like a small pot study. So like, I guess for this group right here, what I was thinking is that they might grow tomatoes and then apply urea and like 13 and then some poultry litter or some organic material to a little small group of pots and see, and then we'll harvest the plants after a month and we'll see which one took up the most nitrogen. Right? I mean, y'all, I need just a simple project. All right, and I got a feeling that y'all might have something similar.
Yeah, we have something in the works.
right, but like there should be a couple of treatments and a comparison among the treatments,
And then your control.
and then you're gonna and a control, and you're gonna make a graph out of it, and you're gonna say we found that this particular worked better. That's gonna be y'all's project. Okay.
No, always.
Yeah, no, we've been doing this math thing, but I got the math so that you can do the math when you start your project. Okay? And so maybe that is that y'all go ahead and get some beans. I don't care what you grow. If you want to do beans, do beans. If you want to do a corn plant, do a corn plant. If you want to do just remember, you're only going to grow for about maybe a month and a half, 2 months at most. And all we're really going to test is what's in the soil, what's in the plant, which one took up most better. Okay? And then y'all will probably use this. Y'all will probably use something similar along these lines, maybe, to try and figure out how much fertilizer you need to actually apply. There's going to be something where you grow, like you got to think about a tomato plant in the first month. It's all green, right? It's all plant material. There's no tomatoes. You don't have to harvest anything. You're going to harvest the crop. Probably the root and all. And so maybe that's like in a sandy soil and a clay soil and a loam. Like, I don't know, like y'all can come up with something there. Don't make it too intricate. And if you do make it intricate, I'll stop you. Okay?
I found it today.
What do y'all got going? What's kind of y'all?
So I think we're going to do
A small hydroponic study using our system that we have. We're going to use some of the radishes or carrots or whatever.
Okay, so y'all block of carrots, carrot plants, and 3 fertilizer types. And then radishes, 3 fertilizer types, and then squash, whatever, 3 fertilizer types.
Deal. Squash. Squash.
So, something that's gonna grow up, so you can harvest the crop, and you just measure the fertilizer, the nutrients in the plant material.
Okay.
That's gonna be the final yield.
Okay.
Right? It won't be the actual carrot or just block. You're only gonna grow for a month and a half.
I was just going to measure the rate of like a more objective.
Yeah, measure that too.
Okay.
Yeah, measure the rate of growth, but
And then your final,
tied to fertilizer though.
right, your final thing, you go ahead and see.
Because you're gonna find out that growth and nutrient concentration are
2 weeks straight.
okay? I think that'll be good as far as, I just wanna make something simple for y'all, right?
It's gonna take a couple different sets just because the hydroponic system doesn't have separate reservoirs. So we're gonna use 3 separate sets. So we'll take care of that.
Y'all write that down in materials and methods, and like, you'll give a present, like in, I don't know, I guess it's like 2-3 weeks or something. You'll have to give a presentation on, this is what we're gonna do. We're gonna grow these here's our hydroponic system, and we're gonna grow this. Show me a math calculation of how you calculated your fertilizer rates, and then give me like the final objective that you're gonna kind of go towards. Like, I'm gonna walk y'all through how to do this. Have y'all ever done anything like this before? Nope. So I don't expect you to have a publishable paper by yourselves. But what I would like for it to be is that at the end, we're gonna you'll give a PowerPoint presentation, and then we'll also make a poster.
Right, we'll go ahead and have a visualized.
Well, like I'm going to make a poster and put it by my wall.
Did we try?
And you what? No, we're gonna do it like out in front of Dr. Bear's office, or when you walk along that hallway like Dr. Lucky and Mary.
Research poster.
The research poster. And it ain't gonna be something huge. It'll be. I got 4 posters, and like to get that posted up and see what it is, man. Like y'all get to do something rather than listen to me tell y'all about how the plant takes the stuff and grows, right?
That's right, that's some content. Let's see.
That's right.
They are cool.
What's that? What y'all got going? Okay.
Not as a project.
Okay.
Wow.
What are your
Same
major?
plant.
It's,
Okay.
We're gonna have to. So we get 3 plants, that's more than that has. For all 3 plants. So there are 12 inserts.
Yeah.
And I think it's 4 for each plant.
So we can separate how much we have.
No, so we should make a big one. It is, but like we can use that as trial one. So carrots on that and radishes.
Y'all can do it however you want to.
Tomato.
Like I said, like at the end, basically what it's gonna be is you're gonna.
I feel like that would work, especially if we're gonna be doing specific nutrients.
Alright, hey, no, listen up, alright, so.